Hello everybody. In this video we are going to continue our conversation about exponential functions and their graphs. So in the first video we talked about what an exponential function equation looks like, what specifically about it makes it an exponential versus a linear function. We also talked about the two different kinds of graphs and where we need to look in the equation to determine whether it is a graph that is growing or decaying. So remember, growth means it is increasing from left to right because the b value is greater than 1, or an exponential decay is something that is a graph that is decreasing from left to right because our b value is between 0 and positive 1. So we looked at these two examples right here and we created the graphs in the previous video, but there's a couple things that we need to be able to identify about a graph. So a couple of these words we already have talked about throughout the year, but one of the first ones is going to be the easiest ones for us because we can clearly identify the y-intercept by looking at the equation or looking at the graph. So once you are looking at the graph and you see the point where the graph crosses the y-axis, that is automatically our y-intercept. So if you're looking at this graph, we've already identified that 0, 3 is our y-intercept. Now if you go back to the equation, I do want to point out that we also already know the y-intercept because it is going to be that very first number, not the number in the parentheses, not the number with the exponent, but the number in the front is our y-intercept. So we kind of already know that from the equation, but you can easily find it on the graph. Now the direction. When you're looking at a graph, you have to read it from left to right. So for the first one, we can say that the direction is growth, because it is increasing as you're going from left to right. Now the horizontal asymptote, we identified where you would find that number in the equation, but you can also find it on the graph. Notice that your graph only gets to a certain point and then kind of glides off. Well, that horizontal line is our horizontal asymptote. So for this one, it's going to be y is equal to 0, or you can also say the x-axis is also considered the horizontal asymptote. Same thing. Okay. Now, domain and range, we haven't talked about domain and range, but you're basically going to have the same domain and range for almost all of your exponential functions. So remember, the domain is the x values. So if you go back to your graph and notice that they have arrows, so I'm going to ask you to circle your arrows like we did in previous videos. And we know that this arrow is going up, but it's also going to the right indefinitely. Now this one's going to be a little bit different because normally we would say this right here is going down and to the left. Now it clearly is going to the left, but it's no longer going down because it will not cross this line. So we're going to use that actually for our for our range to determine what the range of that function is. So for your domain, because we have an arrow going to the left and because we have an arrow pointing to the right, we're going to say that the domain is all real numbers. All real numbers, because it goes to the negative x's and all the numbers to the right, which is positive x's. Now your range is going to be a little bit different. So for this one, because it doesn't pass below the x-axis, we actually don't have any negative y values in this graph. So your range is going to be, all the y values are going to be greater than 0. Notice I didn't put greater than equal to because we're not allowed to touch that line. So because we're not touching or falling below, it's just going to be the y values are greater than 0. And that's it. Alright, so if we look at this one right here, we can actually do the same thing. Look at your graph, see where it crosses the y-axis. We can see that by the equation, so I'm going to show you the equation, there's a 2 right here in the front, which matches up with the 2 where the graph crosses the y-axis. So we're going to say 0, 2 is our y-intercept. Because this one is decreasing from left to right, we're going to say that the direction is a decay. It's decaying. Our horizontal asymptote is still the same. Notice it is still our x-axis because there is not a number that's being added or subtracted at the end. So if there's not a number there, it's an automatic 0. So it's going to be y equals 0, or you can say your x-axis. Now, the same thing is going to happen here. Even though this one's going in a different direction, this arrow is going up and it's going to the left. And then if you take this arrow, I do want to remind you that it is going to the left, but it's no longer going down because it's going to hit this line right here that it's not allowed to cross or touch. So for that reason, we're going to say that the domain goes in both directions, to the left and to the right. So that only means the domain is all real numbers. All real numbers. And so the range is going to be the same thing for us on this one, because even though this one's going down instead of going up, the entire graph is sitting on top of the x-axis and it doesn't fall below. So that means we have absolutely no negative y values. So we're going to say that the y values are all greater than 0. Not equal to 0 because it's not allowed to touch the graph or touch the x-intercept, the x-axis. So because it doesn't cross the x-axis or touch the x-axis, it's just sitting above it. It's going to say y is greater than 0. All right. So let's go ahead and look at a couple more examples. Actually, we're just going to look at one more example in this video. So for this one, we are given a function, or not only are we going to identify some of the things that we need to know to graph it, we're going to create the entire graph, and then we're going to name all of those key features on this new graph. So before I even begin, I do want to point out that this 5 in the front is going to be our y-intercept. So we're going to start off with the y-intercept is 0, 5. Now if you want to go ahead and jump over here to your graph, you can find positive 5 on the y-axis, and that would be our initial point. Okay. With that being said, I also notice that our b value is, I'm going to change it to 0.5. 1/2 is the same thing as 0.5. 0.5 is not a number greater than 1. So we now know that this is going to be an exponential decay, which means my graph is going to start high and then it's going to go low. Okay? Because I don't have a number that's being added or subtracted here, then I get to say that the horizontal asymptote is y equals 0. So I'm actually going to take a highlighter here. I'm going to highlight my x-axis to remind me that when I create my graph, I will not touch or cross the x-axis when I create it. It's just going to get really close to it and then start gliding next to it. Alright, with that being said, let's go ahead and create a table so we can add some additional points and give this graph shape. So with that, I'm going to create my x and y. Remember, you want to use small numbers. So I'm going to do -2, -1. We already have the 0, so we're just going to do 1 and 2. And then from here, we can plug in these numbers and find our points. Alright, so I basically took my equation, plugged in the -2, the -1, the 1, and the 2 as my exponent. Notice that the x is at the very top here. And so when I type it in, and then I hit enter, it's going to give me the points so I can graph it. I find it a whole lot easier to graph decimals than it would be to graph fractions. So I want to make sure that these are in decimals. So from here, we can go ahead and add them to our graph. Now we already have our y-intercept, so let's start with -2. Now this one goes all the way up to 20. So I would just imagine the 20 would be way off of my graph, but it is up there somewhere. Okay, so that one we can't graph, but we can do -1 and 10. So we know that that one starts there. And then from here, we're going to go to +1, and we're going to go up 2.5. And then we're going to go to 2, and it's going to be 1.25. Now, obviously, if these numbers get bigger, if I go to 3 and to 4, they're all going to get closer and closer to the x-axis. So from here, I'm going to go ahead and create my graph. If you want to add more numbers to make your graph a little bit more accurate, you can. But I kind of get an idea of what my graph is supposed to look like. So I'm just going to connect these dots. Now, once you get to the x-axis, please make sure you don't touch it or cross it. Just get really close and then start gliding like that. Okay. So I'm going to go ahead and add some arrows here. And then from here, we can identify all the things that we had on the back. Now, there's no need to identify the y-intercept. We already wrote it down. We already have our horizontal asymptote here. So direction, we know that the direction is a decay because we can see that it is going in a downward direction from left to right. We can also look at the equation and see that it is a fraction that is between 0 and 1. So as long as this number is not greater than 1, we know it's going to be a decay. All right, so from here, all we have to do is identify the domain and the range. So I'm going to put dx for domain and then ry for the range. So I'm going to remind you that the domain are the x values. So I'm going to circle my arrows. This arrow goes up, but it's also going to the left, so to -infinity. This arrow is going to continue to go to the right, which is +infinity, but it can no longer go down because it hit a stopping point. So because these two arrows are going to the left and to the right, all real numbers. Now remember, there is a special symbol that represents all real numbers, and you're more than welcome to use it if you don't want to write out all real numbers. Now your range, because it's sitting on top of the x-axis, we have no negative y values. Once again, we're going to say y is greater than 0. Notice it's greater than, not greater than equal to, because this graph is never going to touch or sit on the x-axis. So for this reason, it's y is greater than 0. All right, so this is the last example that we were going to look at together in terms of graphing exponential functions. I hope that the examples that we looked at have helped you identify the y-intercept, to determine what your graph is supposed to look like before you even graph it, and to help you identify some of the points that you could use to create your graph. All right, so with that being said, I will see you guys in the next video.